name is Ricardo Cruz. I'm finishing my PhD in computer science at Inestec in the University of Porto in Portugal. My supervisor is Jaime Cardoso. Professor Joaquim Pinto Costa is also from the University of Porto, and the other authors, Ricardo Prates and Eduardo Simas Filho, are our collaborators from the Federal University of São Francisco Valley and Federal University of Bahia in Brazil. So our idea is to train a convolutional neural network to be background invariant. First of all, we have what is the motivation? We have a data set of electrical insulators, and we have captured them. We have captured most of them inside of a studio. This is going to be our training set, and we also obviously it's easier to capture these images inside of a studio. And then we have another data set that is captured outdoors, outside of the studio, and this is going to be our testing set. So the background changes quite a bit. Well, the object is the same, but the background is different. And the problem with convolutional neural networks is that they can have a very high performance in the normal testing set, where the background is similar to the training set, but then when we change the background, the performance drops precipitously. This is for MNIST. Naturally, it's very easy to get a very high performance in MNIST, but then when we change background, the performance drops. So traditionally, we give the image to the model, and the model does outputs whatever the task is. If it's a classification problem, these are going to be probabilities. So our idea is to have a background generator that generates a background, and then we need to infuse this background into the image. How do we do this? We also have a mask generator that produces segmentation. These segmentations could have been produced manually. Here we decide to use to automatically learn them. So how do we learn this? What do we do with this? So our model, the classifier, or whatever it may be, tries to minimize the loss together with the segmentation, the mask generator, and then the background generator tries to maximize the loss, so that they are being adversely trained. Okay, this is not, again, there is no discriminator, but the idea is similar. One of them tries to minimize the loss, and the other tries to maximize it. So the background generator tries to introduce new backgrounds into the image to fool the model into making mistakes, while the model becomes more robust as a result. Here we are going to do some experiments using MNIST and fashion MNIST, and we are going to change the backgrounds in the testing set and compare them with the original testing set. So the baseline, the traditional, the vanilla convolutional neural network can have a very high performance, but then it drops. Okay, the same thing for fashion MNIST. Our proposal starts off with an accuracy inferior to the one in the baseline, especially in fashion MNIST, but then it remains more robust. So it remains much more robust against background changes. For the insulator, we have also here some results. So the proposal improves on top of the baseline. This attention is something that we mentioned in the poster, if you are interested, or in the paper. The background generator, we try here to change the background generator to see the impact. This uses black background, noise backgrounds. This is a proposal, and this is using real backgrounds. Using real backgrounds is better than our proposal. So here we introduce real backgrounds into the training set. Okay, and it improves on top of the proposal, but the proposal is still very robust. And if you see here a sensitive analysis where we see the derivative of the input relative to the output when going through the model, we can see that the baseline model is much is not insensitive to the background. So the background perturbs it quite a bit, while the output of our model is much more insensitive to the background. It focuses mostly on the insulator. As a conclusion, sometimes it's easier to collect data inside of the studio rather than outside of the studio. And we like our models to be invariant to background changes. And the way that we propose this is to use adversarial training. So we minimize the loss, our model minimizes the loss, and we have a background generated that maximizes the loss. We have to segment the object. This can be done manually, or it can be automatically, as we have done, and supervised in an unsupervised way, as we have done. But that is the idea. And this can be done for regression problems, segmentation, reinforcement learning tasks. Furthermore, usually we use adversarial training, like in GANs, to produce content for the user. Here the idea is to improve the classifier itself, so the concept is a little different. We have some other work on this, not on making the model, not on background, but using this idea of using adversarial training to improve the classifier. If you're interested, I always suggest to see also the work of my colleagues. Thank you very much for your interest. Let me know if you have any questions.